So in this video I'm going to talk about multiple bonds and diatomic molecules. So multiple bonds are when in a covalent compound or a covalent molecule, two atoms have to share more than one pair of electrons. So a double bond is when atoms share two pairs of electrons or four total electrons. And a triple bond is when atoms share three pairs of electrons or six total electrons. Now, diatomic molecules, there are certain elements that in nature exist in pairs always when they are found by themselves. So like if you ever find just plain hydrogen, it's not just the element H, but it is two hydrogens bonded together. If you find just oxygen, it's always two oxygens bonded together. Now this doesn't mean that when they're in a compound with other elements that they have to have a two. It's only when you find them by themselves. And so they're called diatomics because di means two, and so you've got two atom molecules. And the way that you remember these is by, I always remember Mr. Brinkelhoff. So the seven are bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. So if you're ever asked to write like the formula for oxygen gas, it would be O2. Or for nitrogen, it would be N2. Now the reason why I talk about multiple bonds and diatomics in the same video is because diatomics are sort of a good, easy example of some multiple bonds. So I'm actually going to open up the Elmo here. We're going to take a look at and draw some Lewis structures and look at multiple bonds with some basic diatomics. So let's just look at oxygen. Okay, oxygen has 6 valence electrons. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. So when oxygen is by itself, it's a diatomic. It comes in pairs, and each individual oxygen has 2 unshared electrons that it needs to share to have a total of 8. So essentially what it does is this one moves up here, and this one moves up here, and they each share 2 pairs. So if I was to draw the Lewis structure for that, it would look like this. Now, when you share 2 pairs, that is when you make a double bond. Right? Now, if you look at it, if we look at each individual one, this oxygen has 1, 2, 3, 4, 5, 6, 7, 8. And then that oxygen has 1, 2, 3, 4, 5, 6, 7, 8. All right, let's look at one more. So nitrogen actually forms a triple bond. So nitrogen has 1, 2, 3, 4, 5. And another nitrogen has 1, 2, 3, 4, 5. So you can see that each nitrogen has 3 electrons that need to buddy up. So what they actually will end up doing is all of them will end up buddying up with one another. So you'll end up with 1, 2, 3, 4, 5, 6 in between them, and then another pair on the outside. So when you have 6 shared electrons, that is when you end up having a triple bond. So this nitrogen has 8, and this nitrogen has 8. So that's a very simple example of showing a multiple bond using diatomics. Let's look at one example of a multiple bond given a compound or a molecule other than just one that has the same element. Okay, so the example I'm going to use is carbon dioxide. So carbon dioxide, carbon is the central atom, it's in the center, and carbon has 4 valence electrons. So it needs to have 4 more in order to have a full shell of 8. Oxygen has 6 valence electrons, so it needs 2 more. And so you can see them here. So it needs 2 more electrons. So when they come together, one oxygen on either side is going to attach and share electrons with the carbon. So you can see the oxygens are yellow here, and the carbon's electrons are white. So one oxygen comes in over here and shares with that pair, and the other shares with this pair. But what we're left is still too short for each. The carbon is too short, and each oxygen needs another electron. So the only way they're going to be able to do this is to share more electrons. So what will happen is this oxygen will move over here, and this carbon will move here, and then this oxygen electron will move in, and the carbon electron will move in. So essentially what we end up with is two double bonds on either side. But if we were to add up the total number of electrons, we can still see that carbon then, by sharing two pairs, has 8, and that each individual oxygen then also has 8. So those are some basic examples of multiple bonds, including some that are diatomic molecules.